The alert came in with a number that didn't make sense. Error rate 2% above baseline. That should have been fine. Then 5 minutes later, error rate 8%. Slack started lighting up. Seeing failures on the new version? Only some users affected. Why is latency spiking for a subset of traffic? I opened Grafana. Traffic looked normal. Most requests were healthy, but a small percentage failing consistently. That's when someone posted, "Is this the Canary?" We were running on AWS, EKS cluster in US East 1, about 85 microservices. Traffic averaged around 5K requests per second, with peaks hitting 12K. We used a service mesh for traffic routing. Canary deployments were managed through progressive rollout. New versions received a small percentage of traffic, usually 5% to start. Backend services connected to RDS, PostgreSQL, and Redis. We also had a payment provider integration. CI/CD was handled by GitHub Actions and Argo CD. Monitoring included Prometheus and Grafana. Canary deployments were supposed to reduce risk. Expose issues early, contain impact. Only a small group of users were affected. Most traffic worked fine, but for some users, requests failed. Checkout errors, payment failures. From metrics, overall system health looked acceptable because the majority of traffic was unaffected. It made the issue less obvious. But for the affected users, it was complete failure. First thought, partial rollout bug. Maybe the new version had an issue. We checked logs for the Canary pods. Errors were present, but not consistent. Some succeeded, some failed. Next thought, dependency issue. Maybe the new version interacted differently with downstream services. We traced a failing request. It went through the Canary, called the payment service, and timed out. We traced a successful request. Same path, but it succeeded. We looked at request payloads. They were slightly different. The new version included an additional field, optional, but present. The payment provider had strict schema validation. The new field was not recognized. For some accounts, it was ignored. For others, it caused rejection. That explained the inconsistency. But that still didn't explain the latency spike. Then we looked at retries. The Canary service had a retry mechanism. On failure, it retried 3 times, with no backoff. So a single failed request generated multiple calls. This increased load on the payment provider, which slowed it down further, causing more timeouts. Slack was escalating. Should we stop the Canary? Error rate climbing. Payment provider is slowing down. We had a decision to make. The root issue was a combination of 2 problems. First, a schema mismatch. The new version sent an additional field not supported by the provider, causing intermittent failures. Second, aggressive retries. Failed requests triggered immediate retries without backoff. This amplified load. Even at 5% traffic, the retry behavior multiplied the impact. First step was to stop the Canary. We shifted all traffic back to the stable version. That immediately reduced error rates. Then we disabled retries temporarily to reduce pressure. Next, we fixed the payload, removed the unsupported field. We also updated retry logic, adding exponential backoff and limiting retry attempts. After redeploying the fixed version, we reintroduced the Canary, slowly, monitoring closely. This time, error rates remained stable. Full recovery took about 30 minutes. What failed was not the Canary strategy. It was our assumptions. We assumed the new field would be harmless. We assumed retries would help. Instead, they amplified the problem. Detection was also tricky. Because the issue affected only a subset of traffic, and metrics averaged it out, there was also a gap in integration testing against real provider behavior. Engineering lessons. Canary deployments reduce risk but do not eliminate it. Even small changes can have large impacts when amplified. Retries must be carefully controlled. Schema changes must be validated against all downstream systems. Observability should focus on subsets of traffic, not just global metrics. Partial rollouts can still create systemic issues. In the end, only a small percentage of traffic changed, but it was enough to disrupt everything around it. This is the nature of complex systems.